find the adjoint of a 2 by 2 matrix. Now in this class we can see how to find the adjoint of a 3 by 3 matrix. For that we can take a problem, that is second subdivision of the first problem, the first exercise. That is the given matrix is 2 3 1 3 4 1 3 7 2. For that matrix we can assign a name. Therefore you can assume let A is equal to this matrix. Now for finding adjoint, we need to find cofactors, because we know very well adjoint of a matrix is nothing but transpose of the cofactor matrix. Therefore, we can find the cofactors of each and every element of this matrix A. Now, it is denoted by A11, that is the first row, first column elements cofactor. Now, which is equal to, first we have to assign the sign as we have seen in the previous case. 1 plus 1 is equal to 2. It is an even number. Hence, we can assign plus sign. Then we can find the minor by leaving the first row and the first column. First row and first column, you can get 4 1 7 2. 4 1 7 2. Now, which is equal to plus of. You know very well how to find the value of this 2 by 2 minor. First, you have to find the product of the diagonal element. 4 2s are 8. Then minus product of the anti-diagonal element. 7 into 1 gives 7. This is equal to 8 minus 7 equal to 1. Since it has plus sign, you can get what? Plus 1. Then we can write A 1 2. That is cofactor of first row, second column element 3. Now 1 plus 2 equal to 3 is an odd number. Hence we can assign minus sign. Then we can find the minor. Now leave the first row and second column, we get 3 1 3 2. 3 1 3 2, which is equal to minus of product of principal diagonal 3 2s are 6 minus product of anti-diagonal 3, which is equal to 6 minus 3 equal to 3 minus of 3 equal to minus 3, we can say. Now we can find the A13. A13 is the cofactor of first row, third column element 1. Therefore 1 plus 3 equal to 4 is an even number. We can assign plus sign. Then we can write the corresponding minor. Now see first row, third column. We can 3 4 3 7. 3 4 3 7, which is equal to plus of 3 7s are 21 minus 3 4s are 12, which is equal to 21 minus 12 equal to 9. Here this plus, therefore you can write plus 9. Now we can write A 2 1, that is cofactor of second row, first column element. Now 2 plus 1 equal to 3 is an odd number. Hence we can say minus sign. Then we can find the minor by leaving second row, first column. Leave second row and first column. You can get 3 1 7 2. 3 1 7 2, which is equal to minus of 3 2s are 6 minus 7 into 1 7, which is equal to 6 minus 7 minus 1 minus of minus becomes plus 1. Now we got cofactor of what? A21. Then we can find a cofactor of A22. A22 means 2 plus 2 equal to 4 is an even number. Therefore, we can assign plus sign. Then we can find the minor by leaving the second row, second column. Second row, second column. We get 2 1 3 2. 2 1 3 2, which is equal to plus of part of this one. 2 2s are 4, then minus 3 into 1 equal to 3, which is equal to 4 minus 3 1. Then we have plus sign and put plus 1. Next we can find the minor of second row, first third column element, that is denoted by A23. 2 plus 3 equal to 5 is an odd number. Hence we can assign minus sign. Then we can find the 2 by 2 minor by leaving second row, third column. Second row, third column means 2 3 3 7. 2 3 3 7. Now which is equal to minus of. You can find the product. 2 7s are 14 minus 3 3s are 9. 14 minus 9 gives 5. Since yes minus 9, you can get what? Minus 5. Then we can write A33. This is nothing but the cofactor of third row, first column element. Third row, first column element, which is equal to third row, first column element. Now here, leaving this row and this column, we get 3, 1, 4, 1. And before that, we can assign the sign 3 plus 1 equal to 4. 4 is an even number, you can assign plus sign. Then we can write by leaving third row, first column 3, 1, 4, 1. 3, 1, 4, 1. Now which is equal to plus of 3 minus 4, which is equal to 3 minus 4 equal to minus 1. Since it is plus, you can get minus 1. Then we can write a 3, 2, which is equal to 3 plus 2 equal to 5 is an odd number. Hence you can assign minus sign. Then we can write the minor of the element 7. Now we leave third row and a second column. Then 2, 1, 3, 1. You can write 2, 1, 3, 1, which is equal to minus of 2 minus 3, which is equal to 2 minus 3 equal to minus 1. Minus of minus 1 becomes plus 1. Then we can write A33, which is equal to A33 equal to 3 plus 3 equal to 6, and even number you can assign plus sign. Then we can put the minor. Leave third row, third column, write 2, 3, 3, 4. 2, 3, 3, 4. Now which is equal to plus of 2 4s are 8 minus 3 3s are 9, which is equal to 8 minus 9 equal to minus 1. Since you have plus sign, you can get what? Minus 1. Now likewise we can find the cofactors. Then after finding cofactors, we can find a cofactor matrix that is denoted by either Aij or AC. Therefore we can use the representation AC, nothing else. Okay, now cofactor matrix, write the corresponding cofactors. A11 is 1, then minus 3, write always, then 9, then 1, then 1, then minus 5, then you can take minus 1, then 1, then again minus 1. Now this is the cofactor matrix. Now we know very well the adjoint of the matrix A is nothing but transpose of this cofactor matrix. Therefore we can find the transpose of this cofactor matrix. Now adjoint A is equal to transpose of this matrix, which is equal to 1 minus 3 9, 1 1 minus 5, then minus 1 1 minus 1 whole transpose. That is transpose of this matrix. Now transpose means you know very well, they have to interchange rows and a column. Therefore here we can write the first row as first column. First row 1 minus 3 9. You can write 1 minus 3 9. Then second row 1 1 minus 5. You can write second column 1 1 minus 5. Now you can see the third row that can write as a third column. You can write a minus 1 1 minus 1. Likewise, we can find what adjoint of the 3 by 3 matrix. Okay. Now, likewise, you can find for all the 3 by 3 matrices. Again, since it is a lengthy process, instead of finding this, all these things like this, we can find adjoint of this matrix directly by doing only these calculations. This one is not necessary. If for the first time I write these things, then we can go directly these things. Okay. Now let us do the same problem by another method. The same method we are going to simplify. That is adjoint of this matrix A is equal to transpose of the cofactor matrix, that is ACT, we know very well. Now how to find this transpose means, first we can find the adjoint. For that it is a 3 by 3 matrix, therefore we can put a long bracket because we have to find the values of the minors of all these 9 elements. For that we can find 9 brackets, that is first we can put for the first minor, this is for the second minor, and this is for the third minor. Likewise for the 3 rows we have to write. Leave sufficient space between each column because in between these things, we have to assign plus sign or minus sign. Now we have to take transpose. Now here, this is the first row, first column element. First row, first column element is the cofactor. Therefore, you have to assign the sign. First row, first column means 1 plus 1 equal to 2 is an even number. Hence, you can assign plus sign. Then here, first row, second column, 1 plus 2 equal to 3. 3 means an odd number. Hence, you can assign minus sign. Now here, first row, third column, 1 plus 3 equal to 4 is an even number. You can assign plus sign. Don't write this minus sign in between these two things. Just to write adjacent of this bracket. Many of the students will be writing minus and these pluses only between these two columns. Not like that. Just you write very adjacent to these second column brackets. Now, this is second row, first column means 2 plus 1 equal to 3. You have to assign minus sign. Likewise, we will not find each and every time. Just the first one is plus sign means just you can write the signs alternatively. Plus, minus, plus, then minus, plus, minus. Then after this minus you can write plus, this is minus, this is plus. Row wise also you can get alternate signs, column wise also you will get alternate signs. This you must keep in mind. But now after that, how to find the adjoint, that is cofactor of this first row, first column. Yes, I told already, leave the first row and the first column. You can get 4, 1, 7, 2. Then find the product of 4 2s are how much? 8. Then minus product of this anti-diagonal 7 into 1 equal to 7. Likewise, we can write directly this product by skipping the previous step. Okay. Now, the second one is for this one. If this row, this column means we can get the elements 3 2s are 6 minus 3. 6 minus 3. Now, next one, you take this one. Leave first row, third column. Find the value of this one. 3 7s are 21. Minus 3 4s are 12. Then likewise for this element you leave second row and the first column you can get 3 1 7 2. Here you can take 3 1 7 2 means 3 2s are 6. Then minus 7 into 1 equal to 7. Then next we can come for this element, leave second row, second column. Then you will be getting 2 1 3 2. 2 1 3 2. 2 2s are 4 minus 3 into 1 equal to 3. Now likewise next step. For this one, leave this one, this column. 2 7s are 14 minus 9. 14 minus 9. Now, for this one, leave this one, this column, you get this one. 3 1 4 2. 3 minus 4. 3 minus 4. Then here, leave this row and this column. 2 minus 3. This is 2 minus 3. Now, for this one, leave this row, this column, you can get 2 4s are 8 minus 9. 8 minus 9. Now, the same thing we can write here, that is adjoint of A is equal to, first we can simplify these things. 8 minus 7, 1. You have plus, therefore you can write plus 1. 6 minus 3, 3. You have minus, therefore you can write what? Minus 3. Then this 21 minus 12 equal to 9, plus 9 you can write. Then here, 6 minus 7 minus 1, minus of minus becomes plus 1, we can say. Then here 4 minus 3, 1. Then here 14 minus 9 equal to 5. Since we have minus, you can write minus 5. Then here 3 minus 4 equal to minus 1, you can write minus 1 here. The next one 2 minus 3 minus 1, minus of minus 1 gives plus 1. Then you can write 8 minus 9 equal to minus 1, then you can get minus 1. This transpose we have to write. Just we have simplified. This transpose is very important. Only at the final step we can interchange the rows and the columns. The first row can be as first column, you can write 1 minus 3 9. Now second row can be second column 1 1 minus 5. Then third row can be third column minus 1 1 minus 1. Now likewise we can find the adjoint of a 3 by 3 matrix by skipping extra steps. Therefore, see within 3 steps 1 2 3 we can take the adjoint of this matrix. Otherwise, if you do it in the previous method, it will take a long process. It will take many number of pages. But here, with no time, you can easily find like 2 by 2 matrix. The 2 by 2 is very easy. But here only 2 steps extra we are doing here to find what adjoint of a 3 by 3. Yes, the another problem we can consider the third subdivision of the first problem in the first exercise. The given matrix as 1 by 3 into 2 2 1 minus 2 1 2 then 1 minus 2 2. Now if there is no this 1 by 3, we can easily find adjoint of this one. Since this matrix is multiplied by a scalar, we cannot find the adjoint by skipping the scalar. First of all, we can take this 1 by 3 into the matrix. Therefore, we can write this matrix as, we can multiply each and every element of this matrix by this 1 by 3. 1 by 3 into 2, you can get 2 by 3. Next we can get 2 by 3. Next we can get 1 by 3. Now we can write minus 2 by 3, then 1 by 3, then 2 by 3. Then here 1 by 3, then we can get minus 2 by 3, then we can get again 2 by 3. Now after changing this one, we know very well the adjoint of the matrix A is nothing but transpose of the cofactor matrix AC, the transpose of the cofactor matrix. Therefore, how we can find this transpose of the cofactor matrix? Therefore, we can write adjoint A is equal to, for as we have done in the previous problem, we can go the shortcut method. First, for the 9 elements, you have to find what 9 minus. For that, we can assign 9 brackets. First bracket, then second bracket, then this is the third bracket. Likewise, for all the 3 rows, we can write the bracket first. For this, you have to take transpose. Now we can assign the sign. Then already we have done this first row, first column means 1 plus 1 equal to plus. You can write plus sign. 1 plus 1 equal to, hence is an even number, you can say what plus sign. Now you know very well, alternatively we can write this sign. This is plus, this is minus, this is plus. Then minus, plus, minus. Then plus, minus, plus. Now, how to find the minor of this one means first row, first column is in first row and the first column. The determinant we got 1 by 3, 2 by 3, then minus 2 by 3, then 2 by 3. Now, for this minor we have to find the value. This is a rough work, we will not do it. Now, we can do it directly. Now for that, first we have to do product of the real diagonal. 1 by 3 into 2 by 3. That is 1 by 3 into 2 by 3 means while multiplying the fractions, we can multiply numerator with the numerator, denominator with the denominator. If possible, you can simplify, but here not possible, then we can multiply 1 into 2, 2 by 3 3s are 9. Therefore, product of this one will be 1 into 2, 2 by 9, 2 by 9, then minus. See, minus into plus minus, already here minus, you put what? Plus sign here. Then we multiply 2 into 2, 4. By 3 into 3, 9. We can write what? 4 by 9. Now this value you have to write here. But for each and every time you will not do like this, you can multiply directly here. Yes. How do you multiply? See, first leave this first column, 1 by 3 into 2 by 3, 2 by 9. You can write 2 by 9, then minus of, this is minus 2, this is 2, minus 4 by 9, minus of minus by 3 plus can get 4 by 9. You have to leave this row and this column. Therefore, you can write minus 2 by 3 into 2 by 3 minus 4 by 9. This will be minus 4 by 9. Then minus part of this one. 1 by 3 into 2 by 3 means 2 by 9. And write 2 by 9. Then next we can go for this one. Leave this one, this column. You can take this part minus 2 minus plus 2 to 4 by 9. You can write 4 by 9. Then minus. We can take leave this one, this column means I have to take first tackle this one, take this one 1 by 9 minus 1 by 9. Now we can find the minor for this element. Leave this row and this column. Leaving this one and this one, you can get this and this 2 elements and this 2 elements. Here you can take 2 to 4 by 9. You can write 4 by 9, then minus. of this one minus 2 by 9. Minus of minus 1 gives a plus 2 by 9. Now we can find for this one means you leave this one, this column, we can get these common elements. 2 2s are 4 by 9. This will be 4 by 9. Then minus 1 by 9. Now we can take for this element, leaves second row and third column, we can take these two. Plus 2 into minus 2, minus 4 by 9. Minus 4 by 9. Then we can take 1 by 3 into 2 by 3, that is 2 by 9. Minus 2 by 9. Okay. Then for this element we can come for this one, leaving third row, first column, we can get these four elements 4 by 9. 4 by 9 minus 1 by 9. 1 by 9. Then we can go for the second element again. Leave this row and this column. We can get these four elements 4 by 9. 4 by 9 minus of this product 2 minus 2 by 9 minus of minus 2 plus 2 by 9 you can get. Now for this last element, leave third row and third column, you can get these four elements 2 by 9. 2 by 9 minus 4 by 9 minus of minus plus, therefore plus 4 by 9 we can write. Now after this we can write, see 2 plus 4 6, you can write 6 by 9. Minus 4 minus 2 minus 6 by 9 minus of minus 6 plus 6 by 9. Then 4 by 9 minus 1 by 9 gives 3 by 9. Then here 4 by 9 plus 2 by 9 equal to 6 by 9. Since I have minus, you can write minus 6 by 9. Now this one 4 by 9 minus 1 by 9, 3 by 9 plus 3 here. Therefore you can write 3 by 9. The last one is minus 6 by 9, minus of minus plus 6 by 9. Next we can go for 3 by 9. Then here 6 by 9, we have minus 6 by 9. Then here again 6 by 9. For this matrix, we have to take the transpose. We have to take the transpose. Yes, if possible, we can simplify. If you simplify, you can get 6 by 9 as 2 by 3. Now this you have to write 2 by 3. Now this you can write 1 by 3. Now again this is minus 2 by 3. Now this is 1 by 3. Now this is 2 by 3. Now this one 1 by 3. Then minus 2 by 3. Now this will be 2 by 3. For this matrix, we have to take the transpose. We have to take the transpose. Now, let us take this one directly. We know very well transpose means you have to interchange the rows and the columns. The first row can be first column, that is 2 by 3, 2 by 3, 1 by 3. 2 by 3, 2 by 3, 1 by 3. Now second row, minus 2 by 3, 1 by 3, 2 by 3. That can be a second column, minus 2 by 3, then 1 by 3, then 2 by 3. Then third row, it's the third column, 1 by 3, minus 2 by 3, 2 by 3. 1 by 3, minus 2 by 3, then this is 2 by 3. Now this is the required adjoint of this matrix. Likewise, we can find the adjoint for this problem. Now this same problem can be done by using the properties of adjoint that we will see in the next class. Just we have seen how to find the adjoint of the 3 by 3 matrix. In the next class, we will see the important properties of adjoint. Now, before that, try to do the same problems which are given in the material for the practice. Therefore, you do all those sums. Then, if you have any doubt, you can clarify with me. Okay, you can contact me at any time. Okay, thank you, children.